All right. Hi. I'm just like to give you an overview of Project 1 for ELC 343. I'd like you to read the handout. The handout explains that what I'd like you to do is to flash an LED light on the board and also to read an input push button switch, and when the button is down, flash a separate LED light on, and when the button is up, flash that LED off. In other words, turn it off. Have the second LED follow the push button as quickly as possible, and you're going to find that there's a limit to how fast that can work. So let me show you what my PSOC Creator project looks like, something like this. Actually, there's only 3 elements here on the schematic. Everything else is just purely off chip components, just for illustration. I've just put it in there to make it clearer what's going on. These LEDs and resistors are actually on the development kit on your printed circuit board, but they're off chip. So the design environment doesn't know about them and doesn't care about them. So this is my input pin. And these pins are called General Purpose Input Output, GPIO. And this is configured as an input pin, but not just any old input. It's configured as a resistive pull-up because when the switch is open, then there's nothing connected to the pin, and the state of that pin would be undetermined. By using an internal pull-up resistor, we guarantee that when the switch is up, the pin will read a logical 1. When the switch is down, it will connect that pin to ground, which will cause it to read a logical 0. The 2 outputs are just conventional digital outputs, and we have them wired to kind of random. When I say random, I mean pins that I've chosen, P00 and P01. We can look at the pins and we can see where the pins are mapped. I've mapped the LED outputs, and I just named these output pins LED1 and LED2. I've mapped them to P00 and P01. We're using LEDs on the board that you get to by wiring directly to connectors. There are other LEDs that are wired directly to pins of the chip. You could use those as well. I specifically ask you to use the ones that you wire to, just so you become familiar with the fact that there are the LEDs that are free that you can wire to and LEDs that are hardwired to pins. This switch 2, is actually hardwired. There's a pin in the chip, and you have to figure out what pin to connect that to to make this work correctly. You look at my code, just to point out, you notice my code is fully commented. It's organized nicely. I use the consistent indentation for structure. So I have my open and closed curly brace for the actual routine. I have open and closed curly brace for my while structure, and they're lined up perfectly. I use the exact same number of spaces to indent each level of indent. And I have comments on pretty much every line of code. Let's go and program the board. I have to turn on my USB in order to make that possible. All right, let's program the board now. Erasing, programming a flash. Great, and if I stop sharing, hopefully we will now be seeing the results. So you can see that LED is flashing at a rate of 1 per second. That's what I want you to do. And I have this push button set up so that if I push it down, it lights up that second LED, and when I let go of it, it goes off. And you might notice there's kind of a lag in when it responds on and off, and I'd like you to explain why that lag is. One of the big challenges of embedded systems is to be able to respond rapidly to certain events, while also maintaining maybe a completely different time scale for repetitive real-time activity. So here's a case where we're flashing a light very slowly at 1 per second, and you might want to respond to a push button event in a microsecond, something 1,000,000 times faster than a second. And how do you do that? Well, we're not doing that very well here, but as we progress, you're going to learn some techniques in this course, or at least in 411, how to do that. You can see that I have my wires here. I have P00 and P01 wired up to the LED pins, the LED connector, and that's how that works. All right, I think at this point that's probably good for now, and we'll good luck with the project.